All right, so we are starting again on 2.6 quadratic functions. So as you can see, this is going to be the section that we're going to be talking about. So anyway, first thing we got to talk about is a zero. So we did talk about this in class, but just remember that a zero of a function is simply another word for the x-intercepts of a graph. So if someone just says, hey, find me the zeros, you can just find the x-intercepts, same thing. So a quadratic function, we say, is typically written as f of x equals ax squared plus bx plus c. And we make sure that a, b, and c are all real numbers and that a doesn't equal 0, right? Because if a equals 0, then you would just have a linear bx plus c, and we want quadratic. All right, so let's just talk about example number 1. So sketch the graph of f if f of x is negative 1/2 x squared. So without even knowing how to graph it, we should be able to graph this one, right? So we do know that x squared, right, the regular function for x squared is going to be that up, right, when it goes straight up. If we multiply it by 1/2 on the outside, right, that's going to be a horizontal compression. Nope, it's going to be a vertical compression. Yep. It's going to be a vertical compression. And then if we have that minus on the end, that's going to be a reflection about the x-intercept. So this is finally what our graph looks like. And then, of course, if we have negative 1/2 x squared plus 4, we can just move that graph that we just did up by 4. All right. So if you notice for all of these, right, there is a point that is the maximum or minimum. We call this point the vertex. And if you notice, there is also symmetry with it, right? So if you notice, the left side and the right side of this line looks the exact same. And it works for every single value. So we call this the axis of symmetry. All right. So the standard equation. So just like, right? So just like how we have for linear, right? Just like how we have the point slope form, y minus y1 equals m times x minus x1 for point slope form. And then we also have slope intercept form, which is that y equals mx plus b. So there are many forms. We even have the general form, right, of linear, which is ax plus by equals c, right? So many different ways of writing a linear, but remember, this one, slope intercept, typically is the best one of all three because every single value in here tells us something, right? M is the slope, B is the y-intercept. If you look at anything else, right, this A and B in the general form and C, they don't really help us out. That doesn't really tell us anything. And even these points, right, we know they're points on the line, but doesn't really help us out as much. Slope-intercept form is the best. So just like that, this standard form is going to be the best way to graph our equations. This form is the best way to graph it. So if we graph the equation, y equals a times x minus h squared plus k. So that is our standard equation. Y equals a times x minus h squared plus k. So again, we make sure that a doesn't equal 0. And we know that the parabola has a vertex at h comma k. So the vertex is going to be at h comma k. That's the highest point or the lowest point, right? Or notice it's minus h plus k. That kind of trips some people up. typically. I've seen that trips up some students. So it's minus h plus k for the h comma k. Basically, the idea behind that is that you could subtract k to the other side, right? So it's y minus k equals a times x minus h squared, which kind of looks very similar to the parabola that we've talked about in the past, but we're just adding that k to the other side. So that's kind of where we get that idea. All right. So we have a vertical asymptote at h comma k. We also have, vertex at h comma k. We also have a vertical axis of symmetry. And that's going to be at x equals h. So that line, that vertical line, x equals h, is going to be our axis of symmetry. We know that the parabola is going to open up if a is greater than 0, and it opens down if a is less than 0. Again, a lot of this stuff, since we already talked about parabolas, is going to be very similar. We say that the maximum value or the minimum value of a parabola that opens up, that opens down. So the maximum value is when it opens down, the minimum value is when it opens up. And we say that this value is that f of h, which is k. So if I ask you what the minimum value is, it's going to be the k value of your vertex. It's not going to be h comma k, the actual maximum minimum is the y value. So that's just going to be k. All right, so let's actually do some problems. So example number 2. So let's let y equal 2x squared minus 6x plus 4. So first, let's turn it into the standard form. So for this, just like with the circles and the parabolas, we're going to have to use the completing the square. So remember, with completing the square, the biggest thing you have to have is x squared plus bx. There has to be a 1 in front of that x. So if there's something else, first thing we have to do is divide that out. There's lots of ways to do that. That would be what I would suggest, is just divide everything out. So we have y divided by 2 equals x squared minus 3x plus 2. So remember, if you divide one thing, you divide everything by that. So if we divide everything by 2, that includes that y. We have to divide y by 2. So let's also get that 2 off to the other side. Let's make it easy on us. So we're going to have y over 2 minus 2 equals x squared minus 3x. All right, so if we want to complete the square to the other side, remember the way we do that is b over 2 squared. So b in this case is going to be negative 3. So negative 3 over 2 squared is negative 3 squared is negative 3 times negative 3, which is positive 9, over 2 squared, which is 4. So remember the way we do that, that's just going to be y over 2 minus 2 plus 9/4 equals x squared minus 3x plus 9/4. So we simplify the left side, the right side. We know that's just going to be x minus 3/2 squared. Remember, that comes from that b over 2. So you don't even have to do any math with that. You just know that the thing that you squared, that's what you're subtracting. So x minus 3 over 2 squared, that's what you're adding. It was negative 3/2. So that's why we have that. All right. From here, we can just multiply everything by 2 to make it a little easier on us. So we can do, if we multiply everything by 2, we have y minus 4 plus 9/2, because the 2 on the top, 2 on the bottom, equals 2 times everything. So we don't want to multiply that 2 inside because we have the square. So we just leave the 2 on the outside. We can combine these two. So we know that 9/2 is the same as 4.5. So negative 4 plus 4.5 is going to be positive 0.5, or 1/2. So if we subtract that out, we have y equals 2 times x minus 3/2 squared minus 1/2. So we have now put it into our correct form. So let's look at the top, and what's asked for now? So what's the minimum value, the maximum value, what's the axis of symmetry, what are the zeros, and then sketch it. All right, so from there, right, we know that our vertex is going to be at 3 halves, negative 1 half. Remember, we subtract our h, add our k. So since we're already subtracting a value, that's going to be a positive 3 halves. And then we're subtracting 1 half, so that's a negative 1 half. So that means that, let's look, does it open up or does it open down? It opens up because 2 is positive. So let's think about it. If it opens up, are we going to have a maximum or minimum point? We're going to have a minimum. So there's going to be a minimum at negative 1 half, the y value. And then we also know that the axis of symmetry, AOS, the axis of symmetry, is at x equals 3 halves. Now again, the x equals actually matters. This is a line. You can't just put 3 halves. That's a point. We need the actual vertical line of x equals 3 halves. All right. Lastly, let's find all the zeros. So remember, another word for 0 is x-intercept, so we can just make what we have equal to 0. So we have 0 equals 2 times x minus 3 halves squared minus 1 half, and then solve for x. So you can FOIL out the x, but it's already, we have a squared, right? So let's just keep the square and move everything and isolate that. So let's move the 1 half over. So we have 1 half equals 2 times x minus 3 halves squared. We want to isolate the square, so let's divide by 2. So we have 1/4 equals x minus 3 halves squared. So we divide both sides by, we take the square root of both sides. I'm just going to flip it to make it a little easier on us. We have x minus 3 halves equals, remember it's plus or minus the square root of 1/4. Square root of 1 is 1. Square root of 4 is 2, so it's plus or minus 1 half. So if we add 3 halves to both sides, we have, and you can write it as plus or minus 1 half plus 3 halves. I like it. It looks a little nicer to have the 3 halves on the front end, plus or minus 1 half. It also looks kind of like our quadratic equation. So then we just need to figure it out. So x is 3 halves plus 1 half, and x is 3 halves minus 1 half. So at 3 halves plus 1 half, we get 4 halves, which is 2. And at minus, we get 2 halves, which is 1. So those are our zeros. Those are our x-intercepts. So now what we got to do is sketch it. So we know where our vertex is, and we know where our intercepts are. So we said the intercepts, the x-intercepts, is going to be at 1 and 2. And we said, where was our vertex going to be at? It was at 3 halves, negative 1 half. So 3 halves is just 1.5, so that's right in the center. 3 halves, negative 1 half. We know it opens up, so there's a sketch of our graph. All right. Remember the zeros were the x-intercepts, so that's where it crosses the x-axis, and then our vertex was at 3 halves, negative 1 half. And of course, if you wanted, you could put that's where that axis of symmetry would be. All right, let's do another one. So, basically we're doing the exact same thing. So first thing we gotta do is divide everything by 3, so that way we can have just x squared by itself. So we have f of x divided by 3 equal x squared plus 8x plus 50 over 3, because that doesn't really simplify out. So subtract that to the other side so we can isolate our x squared plus 8x. So we're going to be subtracting that to the other side. All right. So completing the square, we're going to have 8 divided by 2 squared, which is 4 squared, which is 16. So we're going to add 16 to both sides. So, to get the right side, right, we're going to have x plus 4 squared. Remember, that's where we get the b minus, or 2, b over 2. And then again, you can combine these now, or if you want to wait, what I typically do is I just wait until after we multiply by 3. Makes things a little easier on us. We don't typically have to use fractions. So after this, let's multiply everything by 3. So we have f of x minus 50 plus 16 times 3, which is 48, equals 3 times x plus 4 squared. Remember to keep that 3 on the outside. Don't multiply it in. So negative 50 plus 48 is negative 2. So if we add that to the other side, our final equation is f of x equals 3 times x plus 4 squared plus 2. So that's our standard form. So that means that we have a vertex at negative 4, positive 2. Remember, it's x minus h, so that's a plus. So that's going to have to switch the signs. And then plus k, so that's what we got. That's fine. We know it's going to open up because the 3 is positive. So since it opens up, we have a minimum. So the minimum value is at 2. The axis of symmetry is at x equals negative 4. Oh. So now we just got to figure out what our zeros are. So figuring out what our zeros are, let's look at our equation. So we have 0 equals 3 times x plus 4 squared plus 2. We do the same thing we did last time. Subtract out that 2. So 2 equals 3 times x plus 4 squared. Divide the 3. Negative 2/3 equals x plus 4 squared. So if you take the square root, you actually can't, right? Because you have that negative. So there are actually no zeros this time. So that means it never crosses the x-axis. So let's sketch it. So we said that we had the asymptote, or we had the vertical axis at negative 4, 2, and we know it opens up. Okay, so it actually makes sense that it would never cross the x-axis. If it's above the x-axis and it opens up, makes total sense that we wouldn't have any zeros. All right, so good way to check ourselves, and that's probably correct. And then again, if you wanted to put the axis of symmetry, you could do that as well. All right, let's do one more. So y equals negative x squared minus 2x plus 8. So again, this is almost correct, except we do have a number that's not 1, it's negative 1. So we just multiply negative 1 to everything. So negative y equals x squared plus 2x minus 8. So you add 8 to both sides, and then complete the square. So for completing the square, we're going to have 2 over 2 squared, which is 1 squared, which is 1. So adding 1 to both sides, we have negative y plus 8 plus 1 is 9, equals x squared plus 2x plus 1. So the right side is going to be x plus 1 squared, because again, it comes from our b over 2. And then negative y plus 9. So multiply everything by negative 1. So y minus 9 equals negative x plus 1 squared. Adding off the 9, we get y equals negative x plus 1 squared plus 9. So that is our final answer when it comes to our equation. So then, of course, that means that we have a vertex at, let's take a second, think about it, negative 1, 9, x minus h plus k. So the plus is the same, so we're good. On the 9, it's supposed to be minus, so we got to flip that sign. We know that it's going to open down because it has a negative out front. So that means that if it opens down, we're going to have a maximum point. And the maximum point is going to be at 9. The axis of symmetry is going to be at x equals negative 1. So finding our zeros, so we have 0 equals negative x plus 1 squared plus 9. That's what we said, right? Yeah. All right, so we subtract that 9. Negative 9 equals negative x plus 1 squared. So you might be tempted to take the square root now and just say, oh, there isn't one, but we can't take the square root until we get rid of that negative. So we multiply both sides by negative 1, or divide by negative 1. I'm just going to flip the sides so it makes it a little easier on us. We get that it equals positive 9. So taking the square root, x plus 1 is plus or minus 3. That's the square root of 9. So then x equals negative 1 plus or minus 3. So x is negative 1 plus 3, which is positive 2. And x is negative 1 minus 3, which is negative 4. So that's where it's going to cross the x-intercept, or the x-axis. So let's graph it. So negative 4, positive 2. We said the vertex was going to be at negative 1, 9, and it opens down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 9, and it opens down. All right, so all that makes sense. Good. Good way to double check yourself. Make sure you got all those answers right. And again, if you want, you can put that axis symmetry, but you don't have to. All right, so what if, so that is one way that you can absolutely do it. So you can do it just like this and you're done forever. Don't have to worry about it. However, there is another way that we can do it. So the general form for our equation is just y equals ax squared plus bx plus c. So what if you don't like to complete the square? What if you just want to do it not completing the square? Just keep it in the general form. Well, you actually can do that too. So on my test, I typically don't care one way or the other. As long as you know how to do it, I'm cool. But, so basically, if you liked what we just did, I think you can probably just skip the rest of this. For the most part. Oh, no, we got to do it the other way. So you can probably skip ahead in the video if you liked what we just did and just go ahead and do that forever. That's fine. That will absolutely work. However, if you don't want to have to complete the square, because completing the square is the worst, then don't worry about it. We don't have to do that. So what we can do instead is that we know that we have a vertex. So I'm actually going to skip the vertex for a second. I'm going to say that our vertical axis of symmetry, our axis of symmetry is actually going to be at x equals negative b over 2a. So the axis of symmetry, we're going to have a vertical axis of symmetry at x equals negative b over 2a, which might look familiar. That's actually the first part of our quadratic formula. So for the vertex, the x value, right, is going to be at negative b over 2a, comma, and then you just plug it in, f of negative b over 2a. So for these problems, you basically just want to find your axis of symmetry first. You plug in negative b over 2a to figure out what your axis of symmetry is. And then since that's your h, right, for that h comma k, you just plug it in to figure out what k is. So same thing, if it opens up, it's because a is positive. It's the same a. If it opens down, it's because a is negative. So the maximum value, again, is going to be when it opens down. The minimum value is going to be when it opens up. And this is going to be that f of negative b over 2a. It's going to be the x value, again, like we said. So as long as you have the vertex, everything else should kind of work out. So let's practice a couple of problems doing the exact same thing. So if you notice, we've actually already done this problem. But let's do it using our other way of doing it. So first, find the vertex. So if we wanted to find the vertex, the way we could do that is y equals, so we know that it's going to be x. First, we got to find the axis of symmetry, right? So actually, we're going to answer part C before we even answer part A. So first, we find the axis of symmetry. That's going to be y equals negative b over 2a. So negative 6 over 2 times 2, which is 6/4, which is 3/2. So the axis of symmetry is x equals 3/2. So then to find the vertex, we just plug it into our equation. So y equals 2 times 3/2 squared minus 6 times 3 halves plus 4. That's how we're going to find our vertex. So we get 2 times 9/4 minus, so 6 divided by 2 is 3. 3 times 3 is 9. And then, of course, 4 divided by 2 is 2. Right? So we get 9 halves minus 5. So remember, 9 halves is 4/5. So that's just negative 1/2. So the actual vertex is 3 halves, negative 1/2. Which means that if it opens up or opens down, so we know that it opens up. So since it opens up, we're going to have a minimum value. And since we already have our vertex, we know that the minimum value is at negative 1/2. All right, so lastly, we just have to find our zeros and then sketch it. So finding the zeros is going to be a little different because we don't have that nice easy square. So 0 equals 2x squared minus 6x plus 4. I was correct on that, right? Yeah. All right. So the first thing we can do is, since everything is divisible by 2, let's just divide everything by 2. Make it easier on us. So 0 equals x squared minus 3x plus 2. So question is, can we factor? So what two numbers multiply gets us 2, adds gets us negative 3. Oh, it actually works out. Negative 2, positive 1. All right. If this didn't work out, then you would have to use the quadratic formula, right? But it did work out, so we see that x is going to equal 2 and x is going to equal 1. So those are our x-intercepts, so we can graph that. X equals 2, x equals 1. We have our vertex at 1/2 negative 1, or sorry, 3 halves negative 1/2. So there we go. And if we notice, that's the exact same thing as our previous problem. So same answers for all of these, we just do it a little differently. Get there a little differently. All right, so let's look at this other one. So again, we've already done this problem. Let's look at it a little differently. So first thing we got to do, if we're not going to use standard equation, if we're just going to do the regular way, first thing we got to do is actually find that axis of symmetry. So the axis of symmetry, that's x equals negative b over 2a. So negative 2 over 2 times negative 1, which is negative 1. So the axis of symmetry is x equals negative 1. So to find the vertex, we just got to plug that into our equation. So y equals negative 1 squared minus 2 times negative 1 plus, let me remember what it is, plus 8. So that's negative, and then negative 1 squared is positive 1, plus 2, plus 8. So we end up with positive 9. So the vertex is going to be negative 1, positive 9. We know that since the front number is negative, it's going to open down. So if it opens down, we're going to have a maximum point. So for part B, our maximum point is at 9, not negative 1, 9. It's at actually 9. All right, then last thing we got to do is find our zeros. So again, might be a little different. So we have 0 equals negative x squared minus 2x plus 8. So we can, again, just multiply everything by negative 1. So that way we can just have a positive x squared, make things a little easier on us. So 0 is x squared plus 2x minus 8. So let's see, is there anything that we can factor? So what two numbers multiply gets you negative 8, adds gets you 2. Negative 4, positive 2. No, that's negative 2. So positive 4, negative 2. There we go. So 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. Good. So we know that x is going to be negative 4 and x is 2. Again, this is where they cross the x-axis. So it crosses at negative 4 and positive 2. And then we know that 3, 4, 5, 6, 7, 8, 9. Negative 1, 9 is our vertex. So it opens down, which is exactly what it should have done. Bless me. All right. So hopefully either one of those two ways makes sense. I'm not going to give you anything like that. So you are definitely going to need to know, if you're going to want to turn it into the standard position, you need to know how to do the completing the square. If you want to do it the other way, you're going to have to remember how you get the axis of symmetry is x equals negative b over 2a. So you're going to have to remember that. But if you don't want to remember that, that's fine. Just make sure to complete the square and put it in the standard position. All right, so for all these, I've given you the equation. You've given me the vertices and everything. So this time it's going to be the other way around. So I give you the vertex and a point, and you give me the equation. So for this one, it's definitely going to be easier to use standard position. So for y equals a times x minus h squared plus k. So our vertex is 2, 3. So we can just plug that in. Y equals a times x minus 2 squared plus 3. So all I have to do is find a, and then we're done. Well, if we have a point, 5, 1, we can just plug that in. So 1 equals a times 5 minus 2 squared plus 3. So 1 equals a times, so 5 minus 2 is 3, 3 squared is 9. Ooh, that's not confusing at all because those don't look the exact same. So 9 and a, hopefully that looks a little different. We can subtract our 3, so we get negative 4 equals 9a. So then a is negative, nope, that's not negative 4, that is negative 2. So we get negative 2/9. So our actual equation is y equals negative 2/9 times, what was it? X minus 2 squared plus 3. And you can just leave it like that. I don't need it to be in general form. This is an actual form that you can use, so that one's fine with me. If you want to leave it like that, I'm cool with it. All right, let's do another one. So find the equation of a parabola that has the vertex at negative 3, 1 and has a vertical asymptote and an x-intercept at 0. So if we have that y equals a times x minus h squared plus k, we can just plug everything in. So the vertex y equals a times x plus 3 squared plus 1. So if we have an x-intercept at 0, what's the point that we are actually going to plug in? So the point we're going to plug in should be 0, 0. So we just plug in 0 for x and y, solve for a, plug it back in, we're done. So 0 equals a times 0 plus 3 squared plus 1. So again, we have 0 plus 3 is 3. 3 squared is 9. Sorry about that. Yep, 9s and a's. Those are not super great for me. So you subtract out your 1, and you get that a is negative 1/9. So when we plug it back into our equation, our official equation is y equals negative 1/9 times x plus 3 squared plus 1. And that would be our final answer. You can, like I said, you can just leave it like that. All right, and that's it. So hopefully, if you have any questions, let me know. Hopefully this wasn't too hard. It seemed very similar probably to the parabola stuff because, again, we are using a form of a parabola. It's just the vertical parabolas, right? So take a look at the homework. If you have any questions, that's what you can text me about or call me about. All right. Everyone have a great day.